Today we are going to be learning about surface area, and we're going to focus just on rectangular and triangular prisms. So a couple formulas that we need are the area of a triangle, which is 1/2 base times height, and the area of a rectangle, which is length times width, or base times height, depending on how you look at it. We are going to use both of those when we're finding surface area today. So first, a couple examples of prisms. This is a triangular prism, and it's not perfect, like there's some holes in it and Kodiak bit right there, but for the purpose of this, it's pretty close to a perfect triangular prism. And a triangular prism has a triangle as a front face and a matching triangle as a back face. And then those triangles are connected by 3 rectangles. So it's called a triangular prism because it has a triangle as a front face and a back face. Then, right here we have a rectangular prism, which is just like a box. Any perfect box is a rectangular prism because they have matching rectangles on opposite sides of the box. So if we are finding the surface area of this rectangular prism, the front face and the back face will be the same, the top and bottom will be the same, and the 2 sides will be the same. So that means if I want to find the surface area, if I find the area of this front face, it's going to be the same as the back face. So let's start with that. Front and back. So let's see, the front or back will be 42 by 64. So to find the area of that rectangle, I'm going to do 42 times 64, which is 2,688. And then I have to multiply this by 2 because the front and back are the same. So that comes to 5,376. Okay, so let's do the side. So sides, so it's 64 is the height times 35 is the base of that side. So 64 times 35 is 2,240. And then we're going to multiply that by 2 because there's 2 sides. 4,480. And then lastly, the top and bottom, which based on this shape should be the smallest area. So the bottom is 42 by 35. So 42 times 35 is 1,470. Yep, that's the smallest. That makes sense. Times 2, because there's top and bottom, 2,940. So here's my top and bottom. Here's the sides. Here's the front and back. To find the total surface area, I'm going to add all of those together. Which comes to 12,796 centimeters squared. That means if I were to wrap this box, because it was a present, I would need 12,796 centimeters squared of wrapping paper. That's how much it would take to wrap the box. So next, triangular prisms, like I told you with the cardboard, the front and back triangle are the same, but then the 3 rectangles could be different or could be the same. In this example, they're going to be different sizes, so we're going to have to find the area of each rectangle. So this front triangle is going to be the same as the back triangle. That's what makes it a prism. And whenever we're finding the area of the triangle, we always have to look at where the 90-degree angle is. That tells us that that's the base and height. So the area of this front triangle is going to be 1/2 times 3 times 3.5. So it's 5.25 is the area of the front triangle. And then let's just multiply that by 2 right now because the front and back are the same. So 10.5. Okay, so we found the area of the front triangle and the back triangle. So now we need to find the area of the 3 rectangles. So rectangle 1 is this one, I'm going to call it, and it's 9 by 3.5. So 9 times 3.5 is 31.5. Then let's find this other rectangle that's kind of hidden. It would be 3 by 9, so that would be 27. And then lastly, the bottom of this prism, the way it's sitting, is going to be 4.5 by 9. 4.5 times 9, which would be 40.5. So we found all the pieces, and now it's time to add them together. 10.5 plus 31.5 plus 27 plus 40.5 is 109.5 inches squared. So if we were to wrap a triangular prism with a perfect amount of wrapping paper, which would be difficult compared to a rectangular prism, we would need 109.5 inches squared of wrapping paper. Now, I know that it can be kind of hard to visualize each side when you're given a 3D shape drawn on a 2-dimensional paper or on your computer screen. So if you're looking at the practice problems on the computer screen, you might want to just draw them on a piece of paper so you can kind of check off once you find each side. Because all surface area is the area of each face that makes up the prism added together. That's it. You all know how to find the area of a triangle and the area of a rectangle. You just have to make sure you find the area of each of the faces and add them together. And in 6th grade, you learned how to draw nets. That might be helpful, so I'll give you a quick example. If we were to draw this as a net, it's like if it's unfolded. So it would have this rectangle as a base, and then it would have 2 triangles kind of as like wings, and then the 2 side rectangles. So if you draw it like that, you could even label the dimensions, but then you could check off each piece as you find the area, so you know you're not missing anything. Okay, have fun with today's assignment of surface area.